Okay, here's a quick tutorial on how to make a rank abundance curve. I've already read in my Chicago tree data. Here's my data frame. I've got all of my species of trees, and I've got the number of individuals of each of those trees. And so to make a rank abundance curve, I need to assign the rank to these. The rank of 1 goes to the most abundant species, rank of 2 goes to the second most abundant, and so on. So I need to sort the data table by the number of individuals. Okay, so I'm going to make a gizmo that's going to do all of the things that I need to do. All right, so let's start with creating a new data frame. I'm going to call it trees.df, or no, I'm going to call it trees, maybe sorted.df. I don't have to create a new data frame, but I kind of want to for some reason. Trees.df, and now remember there's this convention of row, comma, column, so I could pick out rows and columns, and I want to use a function called order. All right, and now in the order I need to pick the correct column that I want to order by, and that column is individuals. And let's see what that does. I'm going to run that. Okay, so now we have trees sorted. Let's look at this. Oh, shoot, I did it from smallest to largest. I need to reverse that direction. So let's go over here. I think I do that with a negative right here. Let's try that. Yeah, that's right. Okay, so now I've got my most abundant individuals. White ash is the most abundant. Second is mulberry. Third is green ash, and so on. So now I've got them sorted, and now I need to create the relative abundance. I don't want to do absolute abundance. I need to do relative abundance. So I'm going to create a new column called trees sorted. So I'm attaching a new column to this very same data frame, and I'm going to call it rel abund. Okay, and that is calculated from trees sorted individuals divided by the total number of individuals. And I can do that just with the function sum. Sum of trees sorted individuals. Okay, so now if I run both of these, it looks like it added a variable here, which is good. Let's see. Over here, here's my relative abundance. Fantastic. All right, so now I've got my y-axis, my relative abundance. Now I need to make the rank, which is going to be my x-axis. All right, so basically I just need to fill in like 1 to, I guess, 103. So let's see. I think the snappiest way to do this is, I think there's a function called dim, which is like dimensions. Yeah, retrieve or set the dimensions of an object. And now let me see if I do dimensions of trees sorted. The reason I'm doing this in the console is because it's like my Scratch. So let's see what that is. Okay, so it returns a little tiny vector with 2 values, 103, which is the number of rows, and then 10, which is the number of columns. I actually want only the first number, so dim trees sorted. Okay, and then if I remember to pick out the values of a vector, you use the bracket notation. So now I think if I hit return, I'm going to get a 103. I did, great. So that's how many rows I want to make. All right, so now I'm going to make up here in the script, trees sorted. I'm going to make a new column called rank, and that is going to be a new vector. Remember, this is how we make vectors of values 1, 2. That's the little semicolon, or the colon. And now I could type 103, and that would actually do the trick. I know that in this case I have 103, but I'm going to do this slightly cooler version down here. I'm going to grab dimensions. So then if I have a different size data frame, this will automatically figure it out. All right, so copy, come up here, and paste. Okay. So now let's run all my code. Let's see what we got. Oh, it added another variable. That's great. Make sure it worked. Yes. 1, 2, 3, blah, 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 blah. Okay. And so then finally, I want to make my rank abundance curve. So plot x is trees sorted rank. Y is trees sorted relative abund. Okay, let's try that. Look at that. Beautiful. Rank abundance curve. If I want to change the y-axis, I could do xlim equals, make a little tiny vector from 0 to, say, maybe I want to go to 120. And if I want to change my y limit, I can do it like that, same way, from, say, 0 to 0.25. All right, let's try all that. Fantastic.